Welcome to my video on Newton's three laws of motion. Newton's three laws of motion all goes back to Isaac Newton, a 17th century English mathematician, scientist, and he's considered the father of classical mechanics, which has to do with movement. And in this video, I want to look at Isaac Newton's three laws of motion. So the first law has to do with an object at rest stays at rest, an object in motion stays in motion unless acted upon by an external force. Really, this gets down to the law of inertia. Things that are moving stay moving, things that are stopped stay at rest unless they're acted upon by some other force. So an example of this would be Newton's first law would be like a book sliding on a table. As you push a book across the table, it's in motion, but the frictional force slows it down. So the inertia keeps it moving, but the frictional force slows it down. When you're in a car and you slam on the brakes for a sudden stop, you lunge forward, but the seatbelt pulls you back. So that's your inertia moving you forward. You're continuing in motion until the seatbelt has a force acting upon you to slow you down. Newton's second law of motion is force is equal to mass times acceleration. And it shows a relationship between the actual force, mass, and acceleration. Here we're turning into a mathematical equation. Force is equal to mass times acceleration. Force has units of newtons. Mass has units of kilograms. And the acceleration is meters per second. So a simple example of this would be like if you're at the grocery store and you're pushing a cart. If it's empty when you first get there, it's fairly light, it moves easily. By the time you get to the checkout and you bought a whole bunch of stuff, it gets heavy. So the mass is increased. It takes more force to move that cart at the same rate of acceleration to get around the store. Another example would be like a rocket taking off. You've got the force of the hot gas coming out of the tail of the rocket, moving the rocket forward. So there you got force is equal to mass times acceleration. A simple example of Newton's law, this is kind of a one-dimensional example. We've got a 10 kilogram object just pushed with a force of 50 newtons. Find the acceleration. So here's our object, and we've got this man exerting a force pushing on it. So in this case, force is equal to mass times acceleration. Now if we divide both sides by m, we get acceleration is equal to force divided by mass. 50 newtons divided by 10 kilograms is going to be equal to 5 meters per second squared. So that's acceleration. And notice the acceleration is in the direction of the force. This turns out to be a vector quantity, and we're going to get into that in more depth in later videos. So Newton's third law has got to do with action and reaction. For every action, an opposite reaction occurs. When you're in a boat and you jump off the boat, it pushes the boat backwards because you're pushing it forward. As you go forward, it goes backwards, an equal and opposite reaction. Balloon, when you release the air from a balloon, the balloon goes one way, the air goes the other way that comes out of it. Same thing with rocket propulsion. So here's a man pushing it looks like a Cheshire drawer or a box. So his action is pushing it forward, but the reaction of the frictional force with the ground is holding it back. So that's an action and a reaction pair. This simple example of this we see every day as we walk about. Our leg and our foot pushes against the ground in one direction, and we go forward in the other direction. So Newton's three laws explain basically how forces affect motion. So they're everywhere, from seatbelts to space travel, and you can't get away with not seeing Newton's law in action. Anything that moves or is at rest is somehow affected by or explained by these actions, by these laws of motion. So notice Newton's laws in action in your daily life. If you look around, you'll notice it. And hope you got something out of this video, learn a little bit about Newton's three laws of motion. And if you did, give me a thumbs up, a like, subscribe to my channel, and I want to thank you for watching.